After spending nearly 5 decades drifting through deep space, Voyager 1 has sent back a transmission that's left scientists stunned. Something in the latest data hints at a mystery that has puzzled humanity for generations: what lies beyond the edge of our observable universe. For decades, physicists have asked, if the universe is expanding, what exactly is it expanding into? Is there a boundary? A frontier? Or are we simply stretching space itself? Now, a spacecraft launched in 1977, equipped with technology older than modern calculators, may have just brushed against the edges of something we've never seen, or imagined, before. The journey of a cosmic messenger Voyager 1 is now over 15 billion miles from Earth, speeding through space at over 38,000 miles per hour. It was never designed to last this long, let alone make discoveries in the unknown realm beyond our solar system. Yet, against all odds, it continues to send back data, revealing that the vacuum of space might not be as empty or random as once thought. The instruments still operational, particularly the plasma wave detector and the magnetometer, have captured something unexpected. Oscillations in plasma and abrupt magnetic field shifts suggest non-random patterns in interstellar space. These signals are puzzling because they do not match any known natural phenomena in the region. Hints of a hidden structure. Normally, magnetic fields in space change slowly over vast distances. But Voyager has detected sudden transitions, as if it's passing through invisible boundaries, zones with different properties, almost like entering another region of reality. These aren't just noise or minor glitches. Some experts believe they could be the first observational evidence of structured space beyond our known universe. Some theorists propose that these may be domain walls, hypothetical boundaries between different quantum phases of space. Others suggest that Voyager might be sensing subtle interactions from adjacent universes or dimensions, concepts that were once purely theoretical. Beyond the known universe. To understand this, we must revisit Einstein's model of the universe. According to general relativity, space itself expands rather than stretching into a void. Galaxies move apart as spacetime grows between them. This expansion, we now know, is accelerating, driven by a mysterious force known as dark energy, believed to make up about 68% of the total energy in the cosmos. But if the universe includes everything, what is it expanding into? Some physicists argue that our universe is like a brane, floating in a higher dimensional space. In this scenario, other branes or universes may exist nearby, and the faint signals Voyager is picking up could be from these other A collision of theories and observations. The strange patterns observed by Voyager 1 have sparked a wave of debate across the global scientific community. While some dismiss them as anomalies, others see them as the first potential evidence of theories that have long existed only on chalkboards and in simulation code. Dr. Lisa Randall, a leading theoretical physicist, has proposed that our universe might be a three-dimensional brane floating in a higher dimensional space. In such a framework, what we perceive as reality could be just one layer of a much larger multidimensional fabric. If this is true, Voyager may be brushing against another brane, a neighboring universe invisible to us, except through subtle disturbances in space. Meanwhile, Dr. Alan Guth, one of the architects of cosmic inflation theory, has suggested that the violent burst of expansion after the Big Bang could have created a foam of universes. These bubble universes might drift, collide, or influence each other through gravitational or quantum effects. Perhaps Voyager 1 is catching echoes of such a collision, signals from the very boundaries between worlds. Other physicists, like Dr. Max Tegmark, believe that reality itself could be mathematical at its core, and what Voyager is detecting might be patterns in the cosmic code, interference from deeper realities where the rules of physics are different. Could these strange fluctuations, abrupt magnetic shifts, oscillating plasma densities, sudden directional changes, be signs that space is not uniform, but structured, like a cosmic lattice. If so, the implications are staggering. We may have, for the first time, measured the edge of our own dimension. Extraordinary. Or just error. Of course, every bold theory must be tempered with skepticism, especially when the data comes from a spacecraft that's nearly half a century old. Voyager 1's power supply is now down to just 4 watts, barely enough to keep a few instruments functioning. Its radioisotope thermoelectric generator, RTG, is decaying, and some components have aged beyond the lifespan of any modern spacecraft. Dr. Suzanne Dodd, Voyager project manager at NASA's Jet Propulsion Laboratory, emphasizes caution. "We're working with technology that's older than many of the scientists interpreting its data," she explains. With this in mind, there's a very real possibility that these signals may be the result of electrical noise, thermal drift, or malfunctioning sensors. At such extreme distances, over 15 billion miles from Earth, even minor calibration errors can cause large interpretational shifts. Cosmic rays, solar remnants, or even interference from distant supernovae could mimic structured signals. Still, the consistency of the patterns across multiple instruments cannot be easily dismissed. The magnetometer and plasma wave subsystem, though aging, are separately detecting phenomena that seem to align, suggesting there may be more than mere malfunction at play. What comes next? To truly understand what Voyager may have discovered, we must look to the future. NASA is now actively developing concepts for an interstellar probe, a next-generation spacecraft that could travel 3 times faster than Voyager and reach even deeper into interstellar space. With modern sensors, enhanced shielding, and far more powerful computing systems, this probe could verify or refute Voyager's mysterious findings. Meanwhile, the European Space Agency is considering adapting its Comet Interceptor mission or building entirely new platforms capable of measuring faint magnetic fields, gravitational anomalies, and plasma structures near the edge of our heliosphere and beyond. In the coming decades, these missions may provide definitive answers